All right, we're going to do the answers to the test review. So hopefully you felt pretty good going through this, but let's make sure that you did it right. For the first one, it says find all the intercepts of the graph of this. So again, the easier of the two intercepts to find is the y-intercept. To do that, we're just going to make x equals 0. So if you were to put 0 in for x, you're going to get -1 over -2, which is 1/2. That's the y-intercept. If we were to do it as an ordered pair, x is 0, y is 1/2. Okay, so that's a pretty simple one. Don't want to forget. Sometimes you forget that one, even though it was pretty easy. Now the x-intercept is a little trickier. To do that, we're going to set y equal to 0. So that's going to give us this equation. And always, when we start out in calculus, students get real nervous about this kind of equation. They think they have to do a lot of complicated things. But the truth is that your intercepts, your intercepts or your solutions, or what sometimes are called roots, those are going to exist on the top part of this. So really you're only interested in when the top equals 0 in order to make this 0. When the bottom equals 0, that's where we end up with asymptotes, or like we are going to learn later, where we might have a hole in the graph. These are what we call discontinuities in the graph. So we're not really interested in this bottom. 2 is not an intercept. It's going to create something else in the graph. The only intercept that we're going to have is when x equals 1. And so our x-intercept for this is 1, 0. So again, with a little bit of understanding, this is actually a pretty simple problem, but this can, kind of frustrate and complicate things if you aren't so sure. Number 2 here says, find the points of intersection for these graphs without a calculator. Now, with the calculator, I can assume you can get y by itself and graph it. And so we'll just do it without, and then you can use your calculator check later. So if I subtract 6x here, I get y equals 20 minus 6x. If I add x squared here, I get y equals -7 plus x squared. Again, we could go on the calculator, put this into y1, y2, make sure we have a big enough window to see where these intersect and use the intersect function on our calculator. But for here, I'm just going to set these now equal. I want to know when this y equals this y. So when does 20 minus 6x equal -7 plus x squared? And because it's a quadratic, I want this all equal to 0. I want the x squared to be nice and plain. So I'm going to add the 6x over. I'm going to subtract the 27. In doing those two things, I'm going to create x squared plus 6x minus 27. Now I'm looking for two numbers that multiply to equal -27 and add to equal 6. Those numbers are +9 and -3. And that gives me x equal -9 or 3. So those are our x values for the intersection points. In order to find the y values, we're going to put those back in. Again, it doesn't matter which one you pick, and in this case, I don't know if there is a clear one that I would pick. If I had put the -9 in, -9 squared is 81. 81 plus -7 is a +74. If I put the 3 in, 3 squared is 9. -7 plus 9 is 2. So when you graph this, you might see this one right away, but maybe that one wasn't showing up on your screen unless you zoomed way out to see it. All right. So those are our two intercepts. And then we get this problem here. It says write the equation of a line that contains both of these points here. So in order to write an equation of a line, we always need a point and we need a slope. So for everything we do, I want you thinking point and slope. Now, as far as the point goes, we can pick either one of these. It doesn't really matter. So I'm going to pick the 5, -2. I'll show you the other one as well. But the slope is what we have to calculate. So a slope is change in y over change in x. So from y to y, from -2 to 5, we went up 7. And from 5 to 6, we went up 1. So our slope is 7 over 1, or 7. Now, some of you might have done y minus y over x minus x, and that's the same idea. I just like to kind of say, well, how did I get from here to here, and then how did I do it for the x? But it makes no difference. All right, I've got my point, my slope. So now I'm going to go y minus the y value. Y minus -2 is y plus 2 equals slope times x minus x value, so x minus 5. Okay, and if you had picked the other point, then your equation would be y minus 5 equals 7 times x minus 6. And these are the same line. So it doesn't matter which one you give me. If you're to distribute the 7 out and move this over, you'll see that you have the exact same line here. So the AP does not care. In fact, they prefer that you keep it simple for them and don't do extra work that you don't need to. All right. So that's page 1.